Hello students, so today in this lecture I will tell you the use of ruthenium based reagent in organic synthesis. That is, this ruthenium tetraoxide is one of the reagent which is used as an oxidizing agent in various organic reactions. So let's see some of the reactions and their mechanism. So one of the things, this ruthenium tetraoxide, this is used as an oxidizing agent, and here in the ruthenium tetraoxide, no doubt the oxidation state of this ruthenium tetraoxide is +8. Here this ruthenium exists as a +8 oxidation state, and it can easily get reduced into +6 oxidation state. So ruthenium in +8 oxidation state can get reduced to +6 oxidation state. Okay, so it means it is going to reduce and it can oxidize some other organic substrate molecule. Okay. So this ruthenium tetraoxide, this is one of the very expensive reagent. This is very expensive, and that's why it is used as an catalytic amount only. That is, in very small amount it is used. So expensive, so used in catalytic amount. Okay. So one of the things, when we use this ruthenium tetraoxide, then we can use some of the solvents that we can use with ruthenium tetraoxide, like we can use carbon tetrachloride, halogen based solvent that we can use. So, or this chloroform that can be used, chloromethane can be used. So these solvents can be used with ruthenium tetraoxide. Ruthenium tetraoxide. Now, so other solvents like benzene, say if you have this benzene or some ether, so these reagent it cannot be used with the ruthenium tetraoxide. So ruthenium tetraoxide, it's being electrophilic in nature. So that's why this is quite electrophilic in nature. So benzene being electron rich, so that reacts with this ruthenium tetraoxide. So this benzene, ether can't be used with ruthenium tetraoxide. Okay, due to the high electrophilic nature. So due to its electrophilic nature. Okay. Next thing, this ruthenium tetraoxide. This ruthenium tetraoxide, as I told, this is expensive, and it is used in catalytic amount or it is used in a very small amount. So after consumption of this ruthenium tetraoxide, so how we can use this large amount of how can we use the oxidation of this large amount of organic substrate. So that's why some alternating this oxidizing agent can be used with ruthenium tetraoxide. So or we can say some co-catalyst can be used, some co-oxidizing agent can be used with ruthenium tetraoxide. So some co-oxidizing agent used with ruthenium tetraoxide are, suppose we can use sodium metaperiodate or sodium oxychloride can be used as a co-oxidizing agent with ruthenium, or sometimes we can use some other salt of ruthenium also. So That means these co-oxidizing agent, they will regenerate the this ruthenium tetroxide. So we can write they regenerates RuO4. Okay. Now, so some of the combination that can be used, for example, we can use ruthenium trichloride with, or we may use ruthenium trichloride trihydrate plus sodium periodate, metaperiodate can be used, or we may use ruthenium oxide with NaOCl, or ruthenium tetraoxide with this sodium periodate that can be used. So these are the various combinations that we can use on solvent that we use, that is carbon tetrachloride, or these can be used, or acetonitrile can be used as a solvent with it. Okay, so let's see another thing, what type of reaction that it can oxidize. So it oxidizes this primary alcohol that can be oxidized to, primary alcohol is oxidized to, first it will be oxidized to aldehyde, and finally after another oxidation it will be oxidized to acid. Similarly, if we have a secondary alcohol, the secondary alcohol that can be oxidized to, no doubt it would be oxidized to ketone. Okay, or if we have any alkenes, it can break this alkene molecule also. Suppose if we have a double bond, so this double bond, finally first of all it would get converted into the diol, and then it breaks and it may get converted into the, suppose I write 2 molecules of this. Okay. So these are some of the reactions, and as this is a very strong oxidizing agent, even it is stronger than this osmium tetroxide or its KMnO4. So the reactions where we cannot, where this KMnO4, osmium tetroxide, or ozone, where it is not successful, then in that case we can use the ruthenium tetroxide. Okay. So let's see some of the reactions. So first of all, the mechanism of this oxidation of alkene. Okay, suppose if we have this alkene molecule, so let's see the mechanism of oxidation. Suppose if we have this alkene, okay, and in presence of this ruthenium tetroxide, okay, so it will form a cyclic transition state. Here, now, here, suppose if we have a nucleophile, so nucleophile can attach over here, and so this bond will get broken. Ruthenium carbon bond being weak, this will get broken, and finally we can get O minus. This is ruthenium, and this is suppose OH2 plus. In next step, one of this proton transfer will occur, and what we can write in the next step is OH, and this proton transfer will occur, and we can write over here OH here. Now again this H2 molecule, so it may attack over this ruthenium, and Okay, so now in next step what will happen? So this ruthenium oxygen bond will again break, and we have this diol. We have this diol, and plus we will get this ruthenium in +6 oxidation state. So we can see here ruthenium initially, which was present in +8 oxidation state, it is now reduced to +6 oxidation state. So now, so how it will oxidize the other molecule? So that's why it can get oxidized by using, suppose, sodium metaperiodate. So this sodium metaperiodate in a reaction mixture will again oxidize this into this ruthenium tetraoxide, and it can act further. Okay. Now this diol, it will break, and again what we can do, it will get oxidized. After this oxidation, what we will get? We will get 2 molecule of, here this one OH, this is another OH, and 2 molecule of this, and further this H2O molecule will leave out, and that will be converted into 2 molecule of this. Okay, so this is the simple mechanism for the oxidation of alkenes. Now let's see the example. Suppose if we have alkene, so this is the alkene, and this in presence of ruthenium tetraoxide, and what will be the product here? So first of all, according to the mechanism, that would be converted into diol. Now further this bond will break. So one of the OH that we can write over here, another OH we can write over here, H2O will get removed, and after that we will get one of this keto group will come over here, and this one that would be converted into CH3, CH2, and this will convert into aldehyde first. This would be converted into aldehyde and then converted into acid. So this would be the product. Now suppose next one, for this one, what would be the product? Now again we can convert this one first into the diol. That can be converted into diol, break this bond, and that will be converted into acid, and finally into the, suppose what we can write, CH3, CH2, this is OH, 2 molecule of this, removal of this H2O molecule, 2 molecule of H2O will get removed, one from each this molecule, and we may write CH3, CH2, CHO, and finally again it will get oxidized, and that will be converted into propanoic acid. So this should be the product in this case. Okay. So this would be the, I should write here CH3, this one, and ethanoic acid. That should be converted into ethanoic acid. Now another example. Let's see, suppose if we have this one and we have ruthenium tetraoxide, then what will be the product? Again, first of all, that will be converted into this here diol. Take this bond and again it will get oxidized. It will get oxidized into this COOH and COH. This would be the product in this case. Okay, so these are certain reactions. Or suppose if we have now, so what should be the product here? In the same way we can write the product. CH2, this is OH, sorry, this is OH over here, we can write OH over here. Now take this bond, okay, take this bond, and this part being the secondary alcohol, that would be converted into ketone, and this one CH3 CH, that would be converted into acid. So here this would be the product. So these are some of the examples for the oxidation of ruthenium tetraoxide. Oh, thank you.